Hi, welcome to 3.1 Part 2. We're starting on page 4 of your packet, and we're going to start with the quotient rule. So quotient is division, and so we're going to take a look at what happens when we expand an expression like this. So we've got w to the 7th, which means w times itself 7 times. And then on the bottom, we've got w squared, which means w times itself twice. Now, when I have w divided by w, that's 1, because anything divided by itself is 1. So these guys essentially cancel out, these guys cancel out or become 1, and then all we have left is w times itself 1, 2, 3, 4, 5 times. So that's w to the 5th. Doing the same thing here, we would have j times itself 5 times. And then we have k times itself 8 times. And then on the bottom, we have j times itself twice and k times itself 5 times. And so when we do all of our cancellations, we have j to the 3rd and we have k to the 3rd. And if we look, we can see that that's subtraction. On this one, we would have 7 minus 2 gives us 5. 5 minus 2 gives us 3, 8 minus 5 gives us 3. So the idea is that we are taking the exponent on the numerator and subtracting the exponent on the denominator. Okay, so we're gonna skip this. I'm just going to tell you that yes, it holds true, and our general rule looks like this. We're going to take x and then the exponent on that minus the exponent on the bottom. So as long as you have the same base, you're taking the top exponent minus the bottom exponent. So let's do the first one together. And this one we have x, and we're going to take 17 minus 10, and we get 7, so it's x to the 7th. Okay, go ahead and try the rest of those on your own. Pause it while you do that, and then come back to take a look at the answers. Okay, our answers look like this, and on this one, if you had w to the 1st, that's fine. W to the 1st and w are the same thing. Same thing here, 4 to the 1st and 4 are the same thing. Okay, moving on. So sometimes we have something where our our exponent on the numerator is less than our exponent on the denominator. So if I take 9 minus 10, I would get -1. On this one, I would get z to the -2. And on this one, I would get h to the -3. And then the kind of little story that goes along with it to help us remember what happens to negative exponents is that if it's negative, it's unhappy, it's not in the right place. Or I've also heard people talk about it as like, this is the 2nd floor of the apartment and this is the 1st floor of the apartment in the denominator, and then they would switch if they're unhappy, if they're negative. Okay, so right here, let's take a look at what happens when we do that. So this would be, if we subtract them, it would be w to the -2. And let's see what that looks like when we expand it. So that would be 5 w's on top. And then on the bottom, we would have 7 w's. And then we cancel out. And so remember, when I'm canceling these out, w divided by w is 1. So on the top, I have 1. And on the bottom, I have w squared. So that means that w to the -2 is the same thing as 1 over w squared. And when we're simplifying things, you cannot have negative denominators. So if a question ever asks you to simplify, which it will a lot, this is what you need instead of that. Only if they ask you for negative exponents can you write something like that. So this one, the same thing, that would be k to the -1, and that's the same thing as 1 over k. So this one is 1 over w to the 2nd, and this one is 1 over k. And then hopefully you'll notice a pattern, and the pattern is you move the base to the denominator and make the exponent positive. Okay, so let's take a look at this one here. And I also kind of think of it as if I have like a smaller exponent on the top and a smaller exponent or a larger exponent here, I think of this one as like winning. It's bigger, so it's going to stay on the bottom. So this one would end up being 1 over x squared because there would be 2 more x's on the bottom. Okay, go ahead and try the rest of these and then come back so you can see what they look like. And those would look like this right here. So you can see what the answers are for that. Okay, moving on. You may remember that when we have something to the 0 power, we say that's equal to 1. And a lot of people feel like that's weird. Why wouldn't it be equal to 0? And so here is why. So if we have something like w to the 7th and w to the 7th, if we were to subtract those exponents, we would get w to the 0. So this is the same as w to the 0. And if we have 7 on the top, it's w times w, and then same thing on the bottom, and then we cancel all of those out or take w divided by w for all of them, we get 1. So if you have the same thing in the numerator and the same thing in the denominator, then you get 1. So this would be the same thing. Our k's to the 5th cancel out, our m to the 3rd cancel out, and then we get 1. And this is, it's the same thing. So w to the 0 equals 1. Okay, and so our exponent rule, and this is just to the power of 0, anything to the 0 power equals 1. So anything to the 0 power equals 1. Okay, and let's see. So let's go ahead and try these so we can recognize which ones are to the 0 power and which ones are not. And notice not all of them are going to be to the 0 power, because then you could just write 1 on all of these. Okay, so this one, they're not the same, and we have more x's on the top. It would be like 5 x's on top and 4 x's on the bottom, which means we have 1 x left on the top, and so we just write it like that, because anything over 1 is just itself. These guys are the same, so they would be 1. These guys are the same, so they would be 1. Okay, you try the rest of them and come back and see what you got. Okay, so those are what your answers should look like on the top. And let's go ahead and try some of the things on the bottom. So these are mixing things up. So we've got kind of a bunch of our rules put together. So like this one, for instance, is just the quotient rule. So it's going to be x to the 2nd. This one is our power rule. Our power rule says that we, if we have a power, we multiply them. So x, 7 times 5 is 7, or x to the 35th. Y to the 8th to the 5th is going to be 40. And if you're having trouble remembering these rules, it might help to kind of write them out and see what's happening. This, you would be writing x 35 times, so I wouldn't do that, but you could at least think about the idea that x to the 7th to the 5th means that I'm going to do x to the 7th times itself 5 times. So if you can kind of picture that that's x to the 7th 5 times, then that's going to give you 35 x's. So we're multiplying. And then this one, when we have this times this, like we have the same base and we have a different exponent, we're adding those exponents. So this is going to be x plus 1 to the 7th. And same thing, if you're having trouble remembering those rules or you tend to get them confused, which is really, really common, then you might think about writing them out. So if I have x plus 1 to the 3rd, that's going to be x plus 1 times x plus 1 times x plus 1, and then times to the 4th x plus 1. I'm going to do that 4 times, and I'm going to end up with a 7. Okay, you go ahead and try some of the rest of these and come back to check your answers. Okay, those are our answers down at the bottom. Okay, moving on, we're going to mix it up even a little bit more. So let's see, I think I will take this one, and I will take this one, and I'll do this one, and then you can do the other ones. So in this one, we've got x to the 5th on top, and then x to the 4th to the 2nd power is going to be x to the 8th power. And so our bigger exponent is on the bottom, so we have 1 over x to the 3rd. And once again, if you're stuck, write them out. It's better to take the time and write them out and to figure out exactly what you're doing than to just make a guess that's quick and is incorrect. Okay, so I'm going to simplify this one a little bit. We've got 3 times x to the 5th times, okay, this is where it gets a little weird. So I'm going to do 2 to the 3rd and x to the 6th to the 3rd. And what a lot of people do on this one is, because they're multiplying the 6 and the 3, they multiply the 2 and the 3. Or they take 2 to the 3rd power and then they take 6 to the 3rd power. But the rules are different. So if we're just taking 2 to the 3rd power, we're going to do 2 times 2 times 2, which is 8. And then x, 6 times 3 is 18. And then I can rearrange these if it helps. And so 3 times 8 is 24. Add those exponents and I get 23. Box in that one. Okay, this one, even more complicated. So I'm going to put that to everything inside the parentheses. So I've got w to the 3rd. 3 times 3 is 9. And then y to the 7th. And then on the bottom I have w to the 3rd and y to the 16th. W to the 3rd, I add these exponents together, and so I get y to the 16th over w to the 3rd, y to the 16th, and since everything's the same, that equals 1. Okay, you try the other ones and then come back and check your answers. All right, that's what they look like. And, oops, you know what? I was showing you the wrong page. That's what they look like. Right there. And then let's take a look at these rules on the bottom. So this is your summary here. This is kind of like everything we've done in 3.1 part 1 and 2 all mixed together. So if we're subtracting and they have like terms, subtracting or adding, combining like terms, this is going to be negative x squared y. And if I take 6w minus, or from 8w, I'm going to get 2w. This one, our rule says we add the exponents, and so this is going to give us h to the 8. I multiply those, so I get negative 14, a to the 5th, b squared. I'm adding my exponents. Those exponents are 1, and I'm adding them. This one, I am multiplying my exponents. So this is going to be x to the 6th. Here I'm going to take that squared to everything in there. So negative 2 squared is 4, m to the 10th times m to the 3rd. So that's going to be 4 m to the 13th. Okay, if I have a fraction like this, I'm going to simplify that. Both of those can be divided by 3. So I'm going to get 9 over 14. And then in this case, one of my x's is going to cancel out, and I'm going to have x to the 4th on top. And this one, I'm going to have y to the 4th over y to the 4th, which is the same thing as 1. And I forgot to do my rule over here. That's going to be xa minus b. And then this one, 1 over x to the a power. That makes this negative 5 over x squared. And that makes this one 1 over 2k to the 3rd. Okay, that's a lot of stuff. It's everything we did in exponents last year, so it's okay if you're a little confused or having trouble remembering. Just put stars by the stuff that's tough for you or that you don't understand, and we will practice in class and answer questions then.